Hey everyone, so as requested, this is the video of me making a very rushed video about rational functions, so let's just start off. So, sorry if this is going to be fast because I'm rushing this. Okay, so let's talk about rational functions. So what exactly is a rational function? Well, it's a function. That's it. It's a function with a rational algebraic expression. But what is a rational algebraic expression? Well, in the simplest terms, a rational algebraic expression is basically just a fraction with polynomials on top of it. This is the definition, but for those who need an even more visual clue, it's going to look a little bit like this. See? Notice how they're both polynomials? Okay, so this is basically it. This is an example of a rational algebraic expression. It's a fraction with a polynomial on the numerator and a polynomial in the denominator. That's it. That's basically it. The only case is this should never ever be 0. The one at the bottom, yeah, never ever equal to 0. Because anything divided by 0 is undefined. Of course. This one can be equal to 0 because it'll just become equal to 0 and it's a constant polynomial. But let's not talk about that. That's gonna be even more confusing. So when it comes to rational functions, there are two things you need to keep track. Number one is the table of values, which is in every function. And number two is asymptotes. So let's go with the table of values. You first start off with x or any other variable. Sometimes it could be, let's say, g of n or h of y. But let's not talk about that. Let's just use something basic, what everybody knows. So you start off with x and f of x, and then you draw a huge table like this. And then you choose your own values over here on the top, not here. You choose your own values because why not? But let's start with something basic. Let's go with something like this. And the next thing I'm going to do is to get your function. Let's say we take something like this. Okay. F of x is equal to 3x plus 1 all over 2. The first thing you have to do is to get your very first value and then copy it and then just plug it in. You just take this. So when you take your very first value, you just take this. What's our x? 2, right? Because it's our very first one. So you just copy it. And then you can use your calculator to do the trick for you. 3 times negative 2 is equal to, well, I'm not going to explain more. I'll just, because I'm rushing, of course. 3 times negative 2 is equal to negative 6, plus 1 is equal to negative 5, divided by negative 2 is, we can write it like this, or if you want, you can also write it as like this. No, sorry. You can also write it like this, or like this, but it's the same. So now we're done with this. We can now remove it and then do another one, which is the one here, because now we try that one. And then we do the process all over again. Then this is 3 times negative 1 is equal to negative 3 plus 1 is equal to negative 2. Divided by 2 is negative 1. Sorry if you don't understand this, but let's just imagine that you already calculated this. And so you do it all over again. And so 3 times 0 is equal to 0 plus 1 is equal to 1. 1 divided by 2 is 1/2 or 0.5. And then how about this one? 3 times 1 is equal to 3 plus 1 is equal to 4 divided by 2 is equal to 2. And then this one. 3 times 2 is equal to 6 plus 1 is equal to 7 divided by 2 is equal to 7.5, which is, put it in, 3.5 or 3.5, but it's essentially the same thing. And that's it. That's your table of values. You can have 3 of these, 10 of these over here, but for the standard one, we're just going to use 5. So now let's look at the asymptotes. There are three types of asymptotes: vertical, horizontal, and oblique. The vertical one looks like this. It's going upwards or downwards. The horizontal one looks like this, which goes leftward or downward, and the oblique is basically just a diagonal. That's it. That's all you need to know. So now we have to find out all of these three asymptotes, because we always have these. You always have these three. No matter what rational function you have, you always have these. So the first you have to do is to take our function. We just copy it. The very first thing we have to find is the vertical. Always have this first. Not this, not this, this. Always have that first. First you have to do is to look at the one on the bottom. What's the one on the bottom? 2, right? So let's add it. 2 equals, we put it into 0. But that's not possible. That can't be right. When this one doesn't make sense, or that's not true, you just remove it and then you write nothing. You can write that, or you can just write this instead. Okay, how about our horizontal one? When we look at our horizontal, asymptote, we're gonna see there are 3 conditions when it comes to this. So, wait. Okay, I'm back. Sorry. So there are 3 conditions when it comes to horizontal. So in horizontal, there are always 3, where the one is. So you know how there's functions, right? And then there's the numerator and the denominator. So there are 3 conditions. If the exponent on the top is higher than the one on the bottom, then if the one on the top is higher than the one on the bottom, then there is none. If the one on the bottom is higher than the one on the top, then the answer is y equals 0. And if they're both equal, the exponents are equal on both sides, you take the coefficient of the leading coefficient of both sides. I'll show it to you later what I mean by that. I'll show everything. You just take it, you just divide it by something. That's something, don't mind that. Okay, so if we look here, which of the following does it fit? Which one of the following does it fit? Which one here? Which one is the larger one based on the exponents? Which one is the larger exponent? The one at the top, right? Which is this one. That means we have none. We have no horizontal asymptote. And oblique. This will only happen if... Actually, no, sorry. This will only happen if it's the one on the top is bigger, and the one on the top is bigger, and it has and the exponent is larger by 1. So let's see. Is this one larger than this one? Yeah, the one on the top is bigger, right? So let's see. The exponent here is which one is the variable? This one, right? What's the exponent? 1. Okay. Okay, how about this one? This is a number. When it's a number, the exponent is always 0. So we notice that this one is plus 1, right? It's plus 1. Great. So the next thing we have to do is to... Okay, remember, this oblique is only if the one on the top is higher and if it's and the exponent is plus 1 of the one on the bottom, which is lower than that. So next we have to do is just to divide it. I'm just gonna skip to the dividing part. After the dividing, it becomes this, and yeah, this is our oblique. That's it. That's our oblique. No, okay. So note is there's going to be a remainder. There's going to be cases where there's going to be remainders here. So if there is, just remove it. Okay, let's try another case. Okay, we have 3 more cases left. Sorry guys, I'm really rushing. I'll just use the table of values for just one case for this one. Let's try this one. Okay, let's try this one. Let's put -2, -1, 0, 1, 2. Okay. So I just skipped it to the part where I calculated. Sorry, but yeah, if you copy everything, you plug in x for everything, this is what you get. So now let's go with the asymptotes. What's the very first one we have to do? Vertical one, right? Okay. So the first you have to do is just to copy the functions. Always copy the function first. That's the very, very first thing you have to do. Always copy the function. Do never ever forget not to copy it. So when it's a vertical, what the first you have to do is look at the bottom. And then get it, and then have it equal to 0. Can we equal it to 0? Yes. Yes, we can. And so we take this, and then we have x plus 3 is equal to 0. Now, what's the next thing we have to do? Just transpose. So we have our x, it stays there. And this 3, which is positive, which you go to the next side, becomes what? Negative, right? So it becomes x equals -3. And that's it. That's our vertical. So now the next thing is you have to look at our horizontal. The next thing is you have to look at our horizontal. Okay. So we remember that in horizontals, there's always going to be cases again. There's going to be 3 cases. There's 2. If there's 3 cases. One is the exponent of the one on top is larger than the one on the bottom, and then vice versa, and then if they're all equal. So if we look here, which one has the larger exponent? The one on top or one on the bottom? The one on top, right? So that means we need this one. Okay, so if the one on the top is larger than the one on the bottom, there is no horizontal. If the one at the top is larger than the one at the bottom, then the answer is y equals 0. And if it's this one, it's a fraction. Notice how we have the one that is larger. So now we have none. Oblique. This is when there's an oblique, you have to ask one question. You have to ask 2 questions actually. Number 1, is the one on the top larger than the one on the bottom? Yes. Yes, it is. Okay, check 1. Number 2, is the exponent on the top plus 1 from the one on the bottom? Let's see. What's the largest exponent on the bottom? 1, right? How about this one? 2. So is 1 plus 1 2? Yeah. So now we know that we can now have an oblique asymptote. So the first thing you have to do is to basically just divide it. That's it. You just divide the polynomials. You can do synthetic, you can do long. But for this one, I'll just do synthetic. Because that's what you guys love so much. Okay, so we bring down, we have 1 times 3, 2, 6. Okay, so now we have, wait a minute. Sorry guys, I added an extra. Oops. So now we have this. So we have x squared, so we minus 1, we have just x. So this is 1x plus 2. We have x plus 2 minus 2, and then just copy the one on the bottom. And that's it. But I told you earlier that if there's a remainder, just remove it. And there's your answer. Our oblique is y equals x plus 2. That's it. Okay. I said earlier that we're going to have 3 cases. So I'm going to make I'm going to give you 2 more. But this time, I won't be able to have the time to give you tables of values. But don't worry, I believe in you guys. I think that you guys can, use tables of values very, very easily. You guys should believe in yourselves. So now we're going to try this one. Let's try. No. Yes. Let's try this one. No. This. Yeah. Okay. So now, let's go with the asymptotes. Let's skip that. So we'll focus here. Not that one, this one. What's the very first thing you have to look at? What's the very first asymptote? This one, right? Okay. So when we look at the vertical, what's the first thing you have to do? You copy it. And then you take the bottom and then you equal it to 0. Can we equal it to 0? Yes. Yes, we can. Did you know that you can actually have more than one vertical asymptote? Yes, you can. You can have more than one vertical asymptote and more than one horizontal asymptote as well. Isn't that cool? No? Okay. So this is a quadratic equation. So we have x squared plus 6x plus 5 is equal to 0. So you can use a lot of things. Whether you can use factoring, you can use completing the square, you can use the quadratic formula, quadratic equations. But you guys may have forgotten that. So if you have, I suggest that you also learn it on a different video. But for now, I'm rushing, so I'll just give you the answers to this. The vertical asymptotes are, the answer to this is x is equal to -1 and -5. So the vertical asymptotes are x equals -1 and x equals -5. That's it. So now, we look at number 2, the horizontal. Remember, when there's horizontal, there are 3 cases. Now let's look here. Which one seems the most fitting? Which one is larger? The one here or the one here? This one, right? That means we take this one. So now let's remember everything. If it's this one, it's none. If it's this one, it's y equals 0. If it's this one, it's y equals something, which I'll teach on the next one after this one. I promise. So because that fits, we have y equals 0. And now oblique. Remember, now let's see. Can this have an oblique asymptote? We have 2 things to check out if we're wanting to look for an oblique asymptote. Number 1, is the one over here larger than the one over here? No? If not, you can just skip it. It has no oblique asymptote. Hooray! Now we have one last case. Okay, so we'll go back to the asymptotes. Again, do not mind us. I don't have the time for that. I'm sorry. So, vertical asymptotes. That is our very first one, right? See, I even put it on a list for you guys. So, what's the first thing you have to do? You copy it. And then you take the bottom and then you equal it to 0. Can you equal it to 0? Yes. Yes, you can. Now you just copy it. Now, over here, the very first thing you have to do is to check for minuses or pluses. And then we have this one, so you just take this one over here. Sorry guys if you don't understand this part. I'm rushing. I'm sorry. So, if you go over here, we notice that we're going to transpose it, so this negative becomes positive. And now we can just divide every part by 2. We have x equals 1/2. Okay. So now, for horizontal, remember, there are 3 possible conditions. Which one is the most fitting? Which one is larger? That's odd. They're both equal. This one has an exponent 1. This one also has an exponent 1. Huh. In that case, we take this one. Remember, this, if it's this one, this is none. If it's this one, it's y equals 0. And if it's this one, it's y equals something. But what is that something? Well, we take a look at what's the biggest exponent here. We look at the variable with the biggest exponent. Our biggest exponent is 1 over here, and the biggest exponent here is 1 as well. So, which of these variables, or which of these terms have exponent 1? This one, right? Which of these terms have exponent 1? This one, right? So now we take this away, the variable, and then we get the numbers. We have 3 over 2. We just copy it, 3 over 2. And that's it. That's your answer. Okay, now let's go back to oblique. Let me rewrite everything just to make it clearer. Okay, remember, in oblique, we have 2 things we have to look for. Number 1, is this one larger than this one? Nope. Then there's no need to continue. And that's it. I hope I can be able to explain more about this in a presentation that I'll make if I have the time this week. And if I don't, I'll just be able to make sure that I can teach you guys if I have the time before something ever happens. So if you guys still don't understand, please make sure to reach out to me, and I'll be able to reach out to you guys tomorrow. Okay, guys, bye.